Hello, everyone. Welcome to Chippy, the Chicago Python user group. My name is Joe Jasinski, and I'm one of the Chippy organizers, and I will be the MC for tonight. So today is our Dunder main meeting. It's hosted typically on the second Thursday of every month. So we're glad to have you all here. And before we get started, I would like to mention our code of conduct. So our code of conduct applies for in our virtual space and in real life. So please be nice to each other. Please review the code of conduct and let us know if you have any questions. So what is Chippy? Chippy is the Chicago Python user group, a Chicago community of Python users. And we've been in operation since 2003, and we started off as a small group meeting in the back of a bar and grew to be one of the largest Python communities in the world. So we have usually about 4 to 6 events each month, and on our various mailing lists and distributions, we have over 1,000 people or thousands of people on Slack and our mailing list and Meetup. So there's a lot of us out there. So one thing I wanted to make a quick note of is that we just, for the very first time, published bylaws and had a formal election. So now we have an elected board. If you're interested in seeing how we do our election process, we have on our GitHub account an account of what our new bylaws are, and here's the new list of people. So Chippy has a number of initiatives, one of which is the Python Project Night. And this is a space and time where we all come together and work on individual or group projects. And it's just an opportunity for people to meet in real space or in current days in virtual space to talk with each other about Python and ask questions about various projects. And sometimes we have other events that go on during that time, like a coding dojo. So it's a really cool event. In addition, we have the world famous mentorship program. And this is where we pair up mentors and mentees who are wanting to learn Python on a similar project, working over the course of a few months. Now, this program is going through a little bit of a reinvention. So stay tuned for information about what the mentorship program turns into. We also have a number of special interest groups, and special interest groups let us dive deep into various topics of Python, such as finance or data sig or web dev and DevOps and algorithms and coding interviews. So if you're interested in learning more about our different SIGs, check out our Meetup page. And speaking of which, here is some upcoming events for Chippy. On May 20th, we have a DataSeg meeting. May 21st, a week from today, we have the Python Project Night. And on June 2nd, we have a meeting of the Web Dev and DevOps SIG. Again, that can be found on our Meetup page. But that brings us to today, the Dunder main meeting. So we have a lot of great talks planned for tonight, and you'll soon hear all about them. But before we get started, I just want to let you know how you can contact us. First of all, we have a Slack channel. If you go to the Join Chippy Slack at herokuapp.com, you can sign up for our Slack list. There's a ton of people on our Slack channels and covering lots of different topics. So feel free to join and learn about what other people are doing and ask your various Python questions. We have a Twitter account that you can follow if you're looking for the latest news about what Chippy is doing. It's at Chicago Python. So feel free to follow us there. And finally, the most important link, chippy.org. If you, all of the links that I mentioned above are accessible via chippy.org. So if you go here, you can, it will act as a landing page for all of our other online presence. So feel free to visit us there. So a little bit of note about how we're going to run tonight. This is our second virtual meeting for the main meeting. And we have a question and answer session after each talk, like normal. But we do that through the side chat or the chat sidebar. So if you have questions for the speaker, or if you want to chat with other people in the group, feel free to post something to the chat. Please note that there's a few second delay between when we broadcast and when you hear the results. So if you could ask questions for the speakers just a little bit before they finish their talk, we'll avoid the chance of dead air. And then I'll read out the questions aloud when they come in, or when we're during the Q&A session. And finally, something you can do, you can also post to the chat. What's your favorite Python module? We'd love to hear what you're using, and you know, what new modules are out there, or what old modules you're having fun with. So post that in the chat. So that's enough of me talking. I would like to start with our first talk, and I'd like to introduce Nate Rock. Let me bring him onto this stream. Hey,
good evening.
Good evening.
Hey.
Hey. So tell me a little bit about yourself. How did you get into Python?
So I actually originally got into Python through finance. Talk a little bit about this in my slides, but I came to Chicago about 12 years ago, in 8 years ago in 2012, and half of my job was using Python 2.7 and pandas to do data analysis for the stock market at Nanex. So by day I would code C++, by night I would do data analysis using Python and pandas. So in fact, we used some of that to present to the Fed, to various entities in the stock market, NYSE, NASDAQ, CME. So it was an integral part of what I did for 5 or 6 years straight every day.
Cool. So would C++ be your second favorite language then?
It wouldn't be my second favorite language. It is a very useful language if you are doing low-level networking and analysis, which you obviously need for the stock markets. So,
cool.
Yeah, I have a love-hate relationship with C++, but Python's my go-to.
Yeah, that's why we're all here.
Mm-hmm.
So yeah, let's take it away, and I look forward to your talk.
Perfect. Excellent. Thank you, Joe.
Thank you.
So tonight's talk is going to be just kind of like an intro to using Python and interacting with this thing you may have heard of, Kubernetes, K8s, all the same thing. Basically, we're not going to go into an in-depth discussion about what it is, but this should just give you kind of like some of the trials and tribulations if you're getting started trying to interact with the Kubernetes cluster using the Python client. So just a little bit of background about me. I'm a senior DevOps engineer at Rally Health. We have open recs. If you want to contact me, you can use nathanielrock@rallyhealth.com or my LinkedIn/Rockhouse. I'm always up to discuss and help people out. We'll have links to both the slides and the code that we're using for this entire presentation available at the Chippy website. So this is just kind of like a pictogram of my history. I was an Eagle Scout, lived in the woods during the summer. Worked in K-12 for about a decade, worked in the stock market for about 8 years, and now I basically work at Rally Health doing Kubernetes-based things full-time. In that line of work, my daily grind basically currently is to take a bunch of apps across the company that are in a Mesos cluster. It's basically just another container orchestrator. Hundreds of devs, thousands of apps, take them and migrate them from running in the Mesos world and facilitate teams to be able to run those same apps in Kubernetes. There's some differences between the two. We're not going to kind of get into the details of that. But in this process, our ops team has created a tool called Dr. Pickle. Dr. Pickle is namesaked after an individual on the ops team named Parker, aka Pickle, and we've just taken his knowledge of Kubernetes and Mesos and just codified it. So Dr. Pickle knows how to talk to Mesos, knows how to talk to Kubernetes, can do things like version compares. And this is the primary focus of tonight's talk. So this is just an example. So in Mesos, you might have an app that's running on the Marathon versions endpoint that gives you a version of an app called K8s Wrangler 1.14.0. And then that same containerized app running in the Kubernetes cluster should also return the same simple JSON format with the name of an application and a version. This is pretty useful as your teams migrate containers in bulk between different environments in Mesos and Kubernetes, and also because we are splitting out and giving each team their own Kubernetes cluster, you now go from kind of a monolithic giant Mesos environment to multiple different Kubernetes environments. So tracking where things are and how they've been migrated is pretty essential. And this kind of goes through some details on some of the techniques we use to create Dr. Pickle. Doesn't have the exact Dr. Pickle code, but all of the techniques you'll see here are used in that tool. So I don't like to talk a lot, but I do like demoing stuff. So on to the demo. Here is a link to the source code for tonight's thing. It will cover how to use Minikube with Kubernetes. We're going to be using two different versions of Kubernetes, version 1.14 and 1.16. Those are not chosen by random. Those are chosen for a very specific reason. And we'll go through a couple different scenarios. The first one is we'll be running our little Kubernetes version app, our K8s Wrangler, locally off the machine, as you might do if you're just developing and want to do debugging locally. You will see it works pretty well. We can hit the REST endpoints, we can get pods, and we can get deployments. The second part of the demo will be running the same application that's been Dockerized and running inside of Kubernetes version 1.14. This is kind of important because up until I think last week or a week before that, a couple weeks, EKS, which is Amazon's Kubernetes offering, only supported up to 114 and 115. I don't believe they had support for 116. However, as we're going to show, going between versions 1.14 of Kubernetes and 1.16 of Kubernetes, if you're coding against it, there's some tricky things you need to pay attention to, because as their APIs evolve from beta to being adopted into the full spec, you've got to deal with some problems. And we'll kind of outline that and show you some examples of that. All right, let's jump into some of the code and some of the demos here. So we'll start out with the code. Basically, you've got your simple Flask application here. We've got two endpoints, deployments, and pods. They're just gets. We've got this K8s Wrangler object that knows how to talk to Kubernetes, knows how to get a list of deployments, knows how to get a list of pods, and output it as a simple JSON. And so we can just take a look at the code for the K8s Wrangler here quickly. Nothing too crazy. It's got an initializer, it's got a get pods function, a get deployments function, and just like a simple main. So if you're debugging locally, you could run this without having to hit the web endpoints. There's also some testing built into this service, or into this repo, but we're not going to get into that for now. All right, so let's clear this out. This is the first scenario. So if we go here, we set it up. This is using a requirements file and virtual environments. So there's documentation in the README. We're just going to skip ahead through that, assume you've got it set up and ready to go. So we're excited, and we're going to run our app, our Flask application. You notice it's up and running. It's listening on port 5000. We can do some very simple curl commands here to just verify that it's working. Let's hit the pods, pass the jQuery. Ta-da! It's showing that there is a K8s Wrangler version 1.14 running in the Kubernetes cluster we're attached to. And we can do the same thing for the deployments. Ta-da! Everything's working magically. We're like, awesome. Our code's great. Our Python code knows how to talk to Kubernetes. Let's take this, Dockerize it, and put it into a Kubernetes cluster. So luckily for you, we have all of the code that you need to do that inside of this project as well. So part of this is we've got our Docker file here. It's based off Python 3.7 Slim, copies requirements. We'll get to this in a little bit. We've installed Git actually for a very specific reason. And then we basically call our app just like we did locally, and it's listening on port 5000. So for those of you who are not familiar with Kubernetes, we'll just take a look at kind of the deployment file here. It's got some more than just the deployments in it, but it's good to go over. And so here we've got the namespace. We're explicitly installing this into the Chippy namespace for this project. So we're going to take our app, put it in the Chippy namespace. So we create our namespace, and then here's the deployment. Nothing too crazy. It's named K8s Wrangler. We want two of these things running so we can do load balancing. And here is the key thing. This is the Docker image that we have built. And if we'd like to see in our Minikube Docker registry, we can do Docker image ls wrangler, and you'll notice, we'll just switch to the 1.4. And you can see that in this particular Kubernetes cluster, I have these two versions of this app running, a 1.14 version and a 1.16. We are going to be deploying the 1.14. So we stop our web application here because we don't need it. We're doing Kubernetes stuff at this point. Very simple way to deploy it. kubectl apply our deployment file. And so it's going to do some stuff. You'll notice it's unchanged. I deployed it before this, but we have a namespace Chippy and a K8s Wrangler app that has been deployed, which is also unchanged. To double check, you can use kubectl like git pods. Get pods -n for Chippy. And you'll notice we have 2 pods running. So our deployment said we want 2 of them running. It's got 2 of them running. We're ready. We're ready to go. Now I'm just going to showcase another tool because we're going to be referencing it again. I like this view a little bit better, especially if you're new to Kubernetes. This is called Lens. It uses the same deployment files that the command line does. So if you can do those kubectl commands, you can use Lens. And for now, we can just verify if we select our unselect default, select Chippy. You'll notice that we have our 2 pods running here. They look green. Things are cool. We can click on it. We can look at the logs. However, we can see when we click on these logs, there's this forbidden message in here. Maybe this is left over from what I was doing before. And so I basically want to be able to connect to this app and just test it out in the browser. I don't know where my browser. Oh, here's my browser. So we come to the web browser. We can get the endpoint inside of Minikube by using Minikube service command. Again, all of this will be documented in the README so that you can just look at the commands that we've been using here. But if I try to attach to that, it will open up the web browser. The root doesn't have it, but the pods does. Man, we're supposed to be getting an app and a version in here. What's going on? It's returning an empty JSON. And again, if we come back here and take a look at these logs, we can see, yeah, there's this forbidden here. Well, if you take your app that you've been running locally and just put it in Kubernetes, and you're trying to talk to the Kubernetes APIs, you're locked out. Basically, it doesn't let you just have access to hit the APIs internally. It uses a mechanism called role-based access control, which you might have heard, which is RBAC. And to solve this particular problem, we just basically need to add a little bit more Kubernetes sauce. So this is the second scenario. We've taken our app that worked perfectly well locally, that we had access and all the rights we needed to talk to the cluster. We've put it in our Kubernetes cluster, and it's failing with an access right. So to take care of that, we have a second deployment file called deployment RBAC. You'll notice it's got the same thing, the namespace at the top, but below that, it has a couple new sections. It's got this authorization that will give our K8s Wrangler read-only access to this, and it has this chunk here that is going to give us access to the extensions API for the deployment resource, and it will allow us to list it. We also have one for the pods that will allow us to list the pods. So you'll notice we've got different resources. We've given different access to them. This will become important as we go between 1.14 and 1.16. You can kind of see this code comment and doubt here, but we'll get to that in a little bit. And then once we've created that, we've basically assigned it a service account, so that's internal to the cluster. And we say, hey, in the Chippy namespace, the app that is named K8s Wrangler has access to do this. So here we are at this point. So if we go back to our code here, we can do our kubectl apply again. And instead of doing the standard deployment, we can do the role-based access control. And you'll notice here it's taken what we've we've gotten. We've given allowance to be able to do it. And now if we go back to our browser and take a look, ta-da, we are able to hit Kubernetes. We've given our app access to be able to read only those things. It's able to communicate using the Kubernetes Python library, and we can just double check deployments. And again, sweet. So this all looks good. Phase 1 is complete. We're now through the first 2 scenarios. It worked locally. We needed to do a little bit of extra stuff to allow it to actually run inside of the Kubernetes cluster itself. And now let's say, management says we need to be on the latest and greatest, stable version, or at least 2 behind whatever the current version of Kubernetes is. Current version is 1.18. And we're like, cool, let's take our app. We know it works in 1.14. Let's deploy that same application to our Kubernetes 1.16 cluster. And so we can just switch on over to that. 1.16, we will do our apply our hardened RBAC things to the cluster. We can go back to our Lens application and just validate that our secondary cluster has the services. You'll notice it says Kubernetes 1.16. We check our pods. We got 2 of them. They're green. We've got some logs. Cool. It's listening on port 5000. We're gold. We are good to go. And so we're actually going to expose this. Whoops. Expose the Kate's Wrangler on port 5000. Oh, it already exists. So I was busy testing before. This should already be here. And we can do our Minikube service 1.16. So we're connecting to the Kubernetes 16 cluster instead. Do it. We open it up. We hit our pods. Bam. We're gold, right? Everything works fine. We're able to hit our pods endpoint, no problem, same exact code. Now, here's where we get into a little bit of trouble. And this is the third scenario that you should be aware of if you're using Kubernetes or Python to talk to Kubernetes. If we try to hit the deployments, oh man, we're back to our empty list. Instead of throwing an error, I'm just returning an empty list. But if we go back and take a look in the cluster in our Lens window here, let's just hit that a couple times because it's load balanced. You never know which one's going to hit. Man, you know what? It's not found. So in this particular instance, between version 1.14 of Kubernetes and 1.16, your code that worked on 1.14 will not work with a newer version of 1.16. Why is this? Well, all of the Kubernetes APIs, something you should be aware of, go through like a beta adoption process and then get adopted back into the main. And as they do that, they go from one named API subset to another. And so in this particular instance, getting a list of pods didn't change. It's the same. It's all core V1 API endpoints. But deployments go from V1 beta 1 to apps V1. So it was graduated from a beta status to a GA status and merged in. And that's what happened between 1.14 and 1.16. We can very easily take a look at the pieces of code we need to change to get this to work. We start with our requirements file. Remember before when I was doing, or we'll actually start at the Docker file. The Docker file for 1.16, I need to install Git. Why do I need to install Git? Well, it turns out they haven't built an official PyPy or cut of the version 12 of this library yet. And so the only way to get this functionality is to actually get it directly from GitHub. So here is a nice way for you to be able to do that. I didn't even really know you could do this, but it was something we needed to do to make this work. So the current code and master for this Kubernetes client will allow us to do it. We use GitHub. We build our Docker file after installing Git. And I've already done all this. It takes a little bit of time. But again, if we do, if we switch over to our Kubernetes 16 cluster and do Docker image list Wrangler, you'll notice we got this 1.16. This image was built off of that. You'll notice it's about 100 megs bigger because it has Git installed on it. Boo. So those are two pieces of code that we needed to change. We also needed to actually go through and change the code itself inside of the Kubernetes cluster. We'll just go through this real quick. There are two spots we needed to change it. In the constructor here, in the init, you'll notice here's this extension's v1 beta 1. We are no longer using that API to connect to it. We're using apps v1, so now it's GA. And then we also have, under the deployment section, instead of us getting the list of deployments using the beta version of the API, we're using this version of the API. So that's basically the changes that we needed to do to make it work in 1.116. So now if we change our Kubernetes deployment file to use that version of the application that knows how to talk this API, we can deploy it. And we'll just redeploy that. You'll notice it changed the app version. And if we're fast enough, we can go back and see the lens here. And you'll notice it's, here's some stuff that's been up for 5 minutes. Here's some stuff that's been up for under a minute. These are our new services. We can see they're listening on 5,000. We go back to our web browser. Boom. Wait a second. It's not working. We have the new code. We knows how to talk to Kubernetes. Remember how that role-based access control came and bit us before? It didn't let us access it. Well, if we go back and look at that file, we actually gave it access to the old API endpoint. So we need to adjust it to be able to give you access to the new API. In fact, let me hit this a couple times so just we can be sure we got the forbidden. In fact, we've got the forbidden. We're not forbidden to hit that old beta API. Or we're forbidden from hitting the new version 1 API. We were able to hit the old beta version. So we can just go to our role-based access controls, and we're going from the old version to the new version under apps. And we go and we reapply that. And you'll notice this on this line, we have updated the role for this particular service. And boom, we are now able to do it. So really, in this example in this set of code I find is pretty useful for people who are getting who are interested in learning Kubernetes, or interested in learning some simple Python stuff, and kind of showcase two of the major hurdles we ran into while creating the Dr. Pickle application as we migrated between different versions of Kubernetes and had this app that was running in Mesos also be able to run inside of the Kubernetes cluster with security rights, with role-based access control. With that, I think I am done. I'm open for any questions if people have them at this point. So what do we have? We've got live stream available later. The stream is being recorded, and a bunch of unicorns. Does if anyone has any questions about this or anything, feel free to post them in the chat. I'll be happy to answer them at this point.
So I think Google is having some technical difficulties, but this we are still recording. So I'm going to ask a quick question: like, how would you, or what have you found that works for automating like the kind of iteration on like building and deploying different Kubernetes resources?
For now, it's just been source managed control. Like I said, up until recently, version 1.116 hasn't been available. So all of the code that we had written that worked with 14 also worked with 15. And then just recently, we spun up a test cluster with the new EKS version, the Amazon Kubernetes cluster, and tested this app. And lo and behold, couldn't find the API. And so part of that investigation was looking through here. Had we been closely following the Kubernetes changes, if you go to the Kubernetes documentation for 1.116, it explicitly says the ability to list deployments has been moved from beta status to GA, and the previously deprecated beta version has been completely removed. And so, but when you're using just the standard Kubernetes commands, like the kubectl commands, your commands don't change between versions, but it's all hidden from you inside of their Kubernetes client, because they know the changes and have migrated it forward. The same goes with Lens. Lens is pretty good about detecting the versions. You could very well, just as you get the versions, look at the release logs and notify yourself. We've actually had discussions about this because of these types of issues, so it kind of broached them inside of Rally when we were discussing what would happen if we upgraded a new one and we just deployed this. And I'm like, it would break. So being able to monitor the release notes and just kind of compare what you have inside of your Kubernetes deployments and your apps versus what is available to that version is definitely something you want to keep up on if you are coding directly against the APIs in something like Python or Go.
Let's see. Do we have any other questions? I thought I saw one pop up. So Ray asked on ShippyTube. I've heard about some tools to aid testing, validating K8S configuration. Any recommendations on technologies for applying software processes to K8S configuration? Not directly. The way we actually interact with Kubernetes at Rally, we actually have an intermediary layer that generates all the Kubernetes configurations for us. But like I said, we have broached the subject before because of issues like this, where you have a major component that you're using, like deployment, very key. Every single app we deploy uses that, and it's now gone from one API to another API. I think we have some discovery tickets as we prepare up for actually getting 1.116 in prod. If anyone has heard of any tools, feel free to share them. I'd be glad to take a look and evaluate them, because that is a great question. And we have a question from Ali Sivji. So how do you set up migrations for a web app in Kubernetes?
Set up migrations.
Database migrations.
Like database migrations. That's outside of the scope of this, but it's just like you do it with any other containerized or Dockerized solution. As you're rolling out your versions, you just need to be very careful about which apps are up and running based off of the schemas. Have a solid rollback plan.
So do you use a Kubernetes job or some other one-off process, or?
It's up to the individual dev teams at Rally. We've got dozens of them, and so each one has their own. Some of them might be doing Ruby, some of them might be doing Python, some of them might be doing, Scala or whatever. So it's really up to them to handle their evolutions or their migrations on their app level. On the ops team, we're not really in charge of that. But I don't think it's necessarily a Kubernetes specific question. It's more, how would you manage your migrations and anything where you could potentially have a period of time at which some apps are not in sync with the underlying database structures.
And we have one more question from Rayberg. Yeah. Is there a way to store your Kubernetes configuration as code?
Yes, in fact, that is 100% what I've done here. In fact, you can see this. It's checked in the repository. It's versioned. You can modify it. You can PR it. You can evaluate it. Other people at the company can do so as well. So this file right here is literally what I sent up to Kubernetes to deploy these applications.
Cool. Well, thank you very much for your talk. That was Kubernetes is a really cool piece of technology, and thanks for walking us through it.
Yeah, not a problem. It was kind of a wham bam laser show, quick run through Kubernetes. I kind of glossed over Kubernetes side of it, but if you're interested in getting started with it, I would definitely take a look at the repo, because you should be able to tinker with it just like we did here in a very simple manner and have some of the security rights and other issues that we ran into at your fingertips to play around with.
Great. We'll post the link to that repo in the comments or in the description for the YouTube video.
Perfect. Thank you.
All right. So let's see. We're going to move on to our next speaker, and that's Erik Johnson. And I'm going to bring him into the stream here.
Hey, how's it going?
Hey, how's it going?
Good. How you doing?
Let me get your banner going here. So, tell us a little bit about yourself.
So I design automation for CenturyLink's CDN. I've been working there for about 15 months. Before that, I worked for SaltStack as a core engineer, senior core engineer for about 6 years. And then before that, I mainly worked as a sysadmin, going back before that. So that's how I first started using Python. We used it to write various maintenance and automation scripts, ad hoc things, in my sysadmin days, that or Perl. But Perl's just not that fun to write. So I tended towards Python.
So aside from Python, what's your favorite language?
So I haven't really gotten a chance to mess around with all the hot new languages that everybody seems to be using these days, like Rust and Go. I just really haven't delved in too much into them. Honestly, what I find myself using, second to Python is Bash scripts. There are plenty of times, especially if what you're doing involves a lot of CLI, as long as you're not doing anything too gnarly with parsing, where it helps to have a higher level language like that. It's like sometimes Bash is just the easiest and best solution, even though it's ancient and nobody seems to use it anymore.
So cool. So I guess, are you ready to start? I guess we'll
Yep.
bring up your screen and
Yep, we just have to.
Sure.
Okay.
Here we go. I'm going to share that.
So, yep. Is that up now?
Yep.
Cool. All right. And this, I'm going to go ahead and paste into Slack when we're done here. Actually, I could just do it now. Actually, I actually prepped it. There we go.
Awesome. Great. Take it away.
Sure. So, any of you who have done debugging before might be asking, why would we use it? Since there's already a debugger that's just built into Python, why would you need anything else? And my answer to that is that I don't like using pudb. It's not very user friendly. You don't get to see the code. You can't see the code unless you run a command to display the current context. It'll show a certain number of lines before and after your current position. It doesn't have a lot of the features that other more modern debuggers have. And even though I consider myself experienced developer, experienced Python programmer, it's just a far more frustrating experience to use that as opposed to pudb. So, and then pudb also gives you a number of other features that you just can't get in pudb. Like you can set watch expressions, so you could put in arbitrary Python code or names of variables, and they'll be evaluated every step you go through the code, so you can watch them change. You can go backwards to the previous function calls, and you can't literally go back in reverse execution, but you can jump back to the previous function call. You can see all of the variable states and all your watch expressions or whatever you have set at the time that function call was made. Further up the stack, which can help with troubleshooting, and one of the nicest features that has come in handy on a number of occasions, especially with the multi-threaded applications, is remote debugging, where it will spawn a debugger that you can telnet into. So this won't be a very long demo. There's not a whole lot to display, so I'm just going to get right into it. To launch pudb, all you have to do is add these two commands. I like to put them on a single line. I think that might be how the upstream documentation for pudb recommends it. Notice it's pu.db, not which is kind of weird, but it doesn't match what you imported. So actually, I'm going to go ahead and switch over to here. First, just by contrast, I'm going to show what PDB is for those who haven't seen it. It's similar. You import pdb.setTrace, and when you do that, you end up here. You're in the debugger, and you can see this is the current the next line that'll be executed. If we look here, that's where we put our trace. And from here, if you want to see what the commands are, you hit question mark. You can see all these commands. I think most of these also work with the shortened versions of them. But L will list your current context. Any of these commands, you can just hit enter and it repeats them. So this is just a look forward. Is looking forward like 10 lines at a time or so. And then if I want to step forward, I hit N. And you can see now I'm at this next line below, and I could keep hitting enter, and it'll keep on going one line at a time. It'll work if it's all you have. Like you might as well familiarize yourself with it. But I tend to, like I said, I tend to avoid it just because it's it's not as fully featured as PDB. So by contrast, I'm going to do the same exact breakpoint here. I'm going to at the same exact point in the code. I'm going to launch into pudb, run the same function, and you get a much nicer debugger. It's the full screen with multiple panes. You have over on the right, you have your current variables. Your locals, you have your previous function calls, your stack here right below that, and if you want to see your it's the same thing. Well, you can hit question mark. You can see all of your different commands, what they do. If I hit N, I can keep going, and if I wanted to. If I wanted to step into a function, if you wanted to go into this function call here, you could just hit S, and now you're in that function. Well, this is like a decorator, but yeah. So now we're in the function. Now we're in a completely different file, and we're stepping through that code. If you want to hit, if you want to continue the execution anytime, you hit the C for continue. And now it resumed execution, right? So some of the other things you can do, you can if you want to see. Let's see. So we have a loop here, right? Let's say we want to just get what the value of the line variable, which is each line in the output. I went over to this variables pane here in the top right, and I'm going to type in line. That's literally just any Python expression. So I could also say like, oops, let me cancel. So now, as I go through the output, now you can see line is updated. I can also set a breakpoint here. So with B at my current position, set another one here if you want. Oops, cancel. Set another one here if I want. You can set as many breakpoints as you want. Now, if I just hit C to continue, next time it hits a breakpoint, it'll stop again. You notice the line has changed here, right? Like I could do, just to show you the effect that you could do any arbitrary expression, I could just do like line dot starts with. I don't know why you would do why this would help, but it's just more of a demonstration, right? Like you can see that, oh yeah, this line does start with Python 3. Cool, right? And then if I go back here, and you can see the next line. Now this line doesn't start with Python 3. So you can, you have a much greater visibility into what you are debugging with pudb as opposed to the built-in pdb debugger. Go back to my notes and see if there's anything here. Anything else? I guess I didn't really put anything else. I did put there are some useful information about the key bindings. It's not an exhaustive list. Obviously, if you want to hit the question mark, you'll see all of them. And then if you want to do something, so the let me back up a second. If what we've been doing so far with the debuggers is it has been focused mainly on stuff that runs in the foreground. So this is good for like scripts or anything else that runs in a terminal. But if you got anything that's a little bit more complex, that has multiple processes or threads that aren't connected directly to a TTY, or that you don't have connected to a terminal, right? Then using either PDB or pudb like this is not going to work because you won't have a terminal to interface with the debugger. And so this is where the remote debugging capabilities come in handy. To do remote debugging, you do need to tell the debugger what the screen geometry is, or what the number of columns and lines are. So yeah, you can. There's a couple different ways I put to get it. I think they both work on both Mac and Linux. I'm not sure about Windows. I try to avoid Windows. I can't speak to that. I'm pretty sure probably neither of these will work there. So you would need some other way of getting the number of lines and columns. And then the call and the import is just a little bit differently. You're gonna import from pudb.remote, and then here's your columns and your lines. Notice that if you run stty size here, it's going to give them to you in the opposite order. You still need it's still like your width followed by your height of the screen, right? And then by default, I believe it's only going to listen. This may have changed. This may be redundant. Now I'm not sure. But I thought that the default was to listen on localhost. It's helpful, especially since I do a lot of development within Docker containers, so I can develop against different platforms. I like to run the debugger on all interfaces because then I can just connect to the Docker container, which is what I'll be doing shortly in my demo of remote debugging. And then you can specify whatever port you want. And so if not, it'll I think it starts from, I don't know, I forget from where 10,000 or something. I don't remember, to be honest. But I just put this in here as an example. If this port is in use, it just counts up, right? So it's going to take the next available port. That's if the port that it wants is in use. And then once the code reaches that point where you've set the trace, you will just telnet directly into the whatever the IP address is and whatever the port number is that it's running on. So going back to my demo screen here. So right here I have, this is in a background, like a multi-processing or process that is not it's like a maintenance process that's not that doesn't run on the console within Salt. It's the GetFS file server update code, and I've already filled some of this stuff in. You can see that here I have 147 width and 37 height. And I'm gonna just pre-grabbing the IP address of the container there, if my trackpad will cooperate. All right, so I'm gonna go ahead and just start up start up the daemon. Actually, this is technically running in the foreground. It doesn't matter. Still gonna hit the same code point. So even if you're not, even if wherever that code break happens is not in the foreground, it's pudb is still going to try to notify you that that the break the trace point has been reached. So it's telling you to telnet into any interface, I guess, on port 9999. So I'm gonna go ahead and do that right now. And say I have the same exact interface. the only difference is that this is all happening over telnet rather than directly in the console. So I'm going to go ahead and show you that if you go ahead and if you were to like change this, if I were to say like I only want this to be 137 by 30, right? Then that's all you're going to get. It's not going to resize if you and redraw if you change your terminal size as well. You're limited by. Oh, that didn't work like the way I thought it would. Oh, no. Yeah, I don't think it likes the fact that I didn't give it the correct size. I honestly hadn't tried that before, and that's like so I've broken the cardinal rule of live demos is doing something different that you wouldn't have done before. But the point is that you do want to make sure that you're telling it the correct screen geometry, or else weird things will happen. So that's really all that I have when it comes to the demo. Just a few more things though to mention about remote debugging. I already did cover the next port will be chosen if the port requested port is unavailable. The other thing is that the telnet instance or telnet server that the pudb creates for you to connect into is not really that robust. You can actually trigger it by running an mmap scan, which I was trying to write some tooling to like check and see if the breakpoint had been reached, because I had a lot of debugging, logging that was like obscuring the actual line that tells you that the trace point has been reached. And I noticed that like it was killing off, or it was never connecting. And I was noticing that the debugger wasn't even running. And I realized that nmap actually triggers the session to start and then immediately closes it. So don't do that. Another thing is that I found that for some people like to use if they don't have telnet installed, but they do have netcat installed. There's a netcat, I think netcat-t or something like that that allows netcat to act as a telnet client, and that actually doesn't work. Same thing happens; it'll immediately disconnect. So you really do need to use telnet in order to connect to it. So that's all that I really have, aside from some helpful keybind or key mappings here that'll might help as a cheat sheet. That said, if anybody's got any questions, I think we can move on to Q&A. I'm sorry, I'm not hearing you.
Helps to unmute, of course.
Yeah.
So thank you for the talk. That was excellent. I think we have one question in the chat. I think that was kind of answered, but it was asking, can you customize your color schemes? And I was wondering.
Good question. I haven't tried to do that before. I could really quick just. I still have one of the debuggers open. I could look at the help here. Preferences, Control P is your preferences. So, yeah, there are several themes built in, and then there's custom theme support. You do need to. It will take a little bit of there's this, you have to create your themes as a .py file. So the answer is yes. There's a number of built-in themes, like some of them correspond to some of the theme themes like Monokai, Solarized, and a couple other ones that are in there. But that would be in the preferences under Control P.
Cool. So question, like, so Python 3.6 introduces the new breakpoint keyword. Do you know if PDB would be able to take advantage of that?
I haven't tried it yet because I haven't written a lot of the stuff that I developed for at work, because I work for CDN, the massive deployment that is very slow moving in what it upgrades. So to be honest, we're still using Python 2, and the Python 3 stuff that we use will probably be what's available on. I think Python 3.6 is available on CentOS 7. So I think eventually come around to using it. But I haven't had the need to actually look into that yet. So I'm afraid I don't know.
Cool.
I would assume that I would assume that probably I would say the next major release may have it if the current one doesn't, because it's been a while since this. I think it's been since like early 2019 since there was a major release of pudb. So and not, I mean 3.6 was already out then, but it was considerably newer then. So I don't know. Cool.
And I have one more question. If since I don't see any else in the chat, if anyone else has any other questions, speak now. But one question I have is, would you be able to use the remote debugging for debugging like a celery task or something like that?
So I haven't used that before. I haven't used celery before. Can you elaborate?
So celery is like a queued job, runs Python in a queue, and
yeah, I mean, so you have to have access to the source code of whatever's running. So, unless you have that, you're not going to be able to launch the debugger. Okay. You have to be able to you have to modify whatever code is running. So, yeah, like anything created with PyInstaller where it's a single binary, you won't be able to use it with. And you might if you're it's a much more useful tool for something where you're developing where you're it's installed and you're running out in like a virtual env for something like that. And I will also occasionally use it. I will if I'm really desperate, I will go into like the actual installed Python module and userlib Python 3. Whatever and edit edit some module that I'm having trouble with and edit it live and use it. But it's not. I guess I'm not 100% sure. But if you had access to the source code of the task, then yes, for sure.
Great. Okay. Thank you very much for the talk. I think we're going to move into a 5-minute break, and we'll return with one last talk from Ryan McCoy. So look forward to that. I'll talk to you soon. Hey, everyone. We're going to start up with our next talk from Ryan McCoy. I'm going to bring him into the stream. And here we go. How's it going?
Hey, Joe, what's up?
How are you?
Having fun, staying inside.
Thanks for speaking with us today. What's how do you use Python?
Me, so I use Python to move data around. I use Python for everything I can find, from data pipelines to Flask to statistics, machine learning, natural language processing, and you name it, I've probably tried it. So I use it for a lot of things.
Cool. So what's besides Python, what's your favorite language?
I probably use JavaScript. The second most. I mean, I've been getting into Go recently. It's interesting. I've used a lot of different things. Excel VBA, VBA a lot. I talk about it in my background, but I use that. And then I switched over to Python, but I try not to use that anymore because it just brings back bad memories.
I guess let's get started. Do you have a screen you'd like to share?
Yeah, I think so. Share screen. Let's see here. We're sharing this screen.
I got to add you to the stream here. Stream. There we go. All right. Looking forward to your talk.
Cool. All right. So my talk today is it's called Spreadsheets, the DataFrames, and a little bit of my background. So I actually have a degree in finance. I worked 10 years in the investment management industry. All of those years I spent doing, Excel VBA because the truth is that everybody in that industry uses Excel VBA for everything. Not everybody, but like 90% of the industry. And I was using it for a lot of things. And I got to the point where I could not do it anymore. Just my data was too big. And, I talk about it in a second, but yeah. So also I co-organize the St. Louis Python meetup. So if we ever get back to normal, maybe check on the meetup, and maybe we'll have an event schedule. So stop by. I've been using Python for about 6 years now. And yeah, so I guess the purpose of this talk is kind of, I started off using Excel VBA, and I found Python, and I, fell in love with it. It was so much easier to use than Excel, and a lot more reliable, you name it. And so this talk is basically kind of like a roadmap of how an Excel user can kind of use what they already know and use that to learn Python maybe faster. And so this is kind of like the way I think about the presentation is kind of a roadmap that I wish I would have had when I first started Python, because I kind of just kind of went in blindfolded and, didn't know what to do. So, that's kind of the purpose of this talk. But, when I was using Excel, I was kind of under the impression that I could use Excel for anything, and you can use Excel VBA for pretty much anything. And, you can do pretty complex stuff, but, it's just not as easy to write as Python. And so that's what main point. But, I built Excel VBA data pipelines, generating reports, automating and schedule things, sending emails, web script. So you name it, I've probably tried Excel VBA as the way to automate that. But, I guess let me get in here, the animations, slideshow from current slide. So, but, to the point is that eventually you kind of get to the point where you are in this situation where you're linking, files to other files, and, it's just not a kind of a good way to go about things when you're building kind of larger scale tools. And so, you have to deal with all these, this is kind of like the last straw that kind of caused me to go from Excel to VBA. And, so my data was getting too big that I couldn't actually use my calculations. I would have to turn it on to manual mode. And so I would have to make all these changes. And then if I wanted to refresh all my formulas, I, pushed it back into automatic. But sometimes, I would get these errors that I would spend 2 hours working on this Excel file, and it would just crash. And it crashed probably about 5 times, more than 10 times. And, I just kept getting these errors, and, trying to work with files is a pain in the butt. Another example of an Excel kind of a pain is, if you try to save a CSV file, sometimes it'll save it like this. And so it's not reliable. And that's a pain in the butt because you cannot fix this. So you better not be working on your primary file. Well, in that lesson, and then you get error messages like this in Excel that you have no idea what is going on. And so then Excel crashes, then you start losing your work. And so, yeah, so these were kind of like the Excel error messages that, came up. And, I tried reinstalling, Office, but then, I still got another error message. And so, that's kind of what led me into Python. After I got these messages, I was like, okay, what am I going to do? And so this is what I call Excel hell. Is kind of like where you're trying to do stuff and you can't do it in Excel because Excel can't handle it. And that part of it is kind of, and I talk about later in the talk, kind of ways to better manage data in general. That maybe would have helped. That would have helped me a lot. But hindsight's 2020. So like I said, the goal of the talk is kind of a roadmap for someone who's using Excel and kind of provide them with a way to maybe use what they know already to learn Python. And so, when I was trying to figure out what programming language I was going to use, this is kind of like situations like what programming language am I going to actually use? And so it's this is an interesting graphic, but here these was maybe might consider the major languages. And so I looked at all of them, when I was trying to figure out what I was going to program, and I tried Java. I was like, oh man, this is so complicated. C++. I was like, what's going on here? And then so somehow I think I ended up with Python. And you hear people say it's so easy, a caveman can do it. And when I first started Python, I brought up the REPL and I was like, what am I going to do with Python? Like I can print hello world, but how do I do anything useful with it? And so that's part of what I want to provide in a roadmap is kind of really are examples that I kind of projects that I've worked on that kind of provided me a kind of easy transition to learning Python. So ultimately, the reason I actually chose Python was because Google used it. And so I was like, okay, well, I'm just going to go with Python. And this is kind of a quote they had early on: Python where we can, C++ where you must. And then so after you kind of like get the hang of Python, this is a great comic kind of talking about just like once you kind of get the hang of Python, you can literally do anything you want. Like, so, you can pause this if you're watching this and just read that comic. It's a great kind of feeling once you get the hang of Python, how it feels to work in Python. So, what can you do with Python? You can automate repetitive tasks, machine learning, natural language processing, data analytics, visualizations. A couple months ago, someone discovered the event horizon or something with black holes. I can't remember. Netflix and Spotify use it. Data analytics at Harvard Medical School, and ride sharing at Uber. So these are kind of like examples that you could use for Python. And so these are tips my tips for learning Python. Come as a former Excel VBA user, try to kick that Excel habit. Instead of opening Excel, open Python and just get used to it. Try to code every day. One of the most important things is, try to find projects that you find interesting. And so I'll talk about a couple of projects that I created to kind of better learn Python. And so everybody works in an industry. Most people work in industry, or if you work in technology, think of an industry that you find interesting. You can go onto GitHub and find data sets for your industry, and you can work with that data to get better acclimated with, Python and particularly pandas. So that, that's a great way to learn something. One of the projects I worked on, because I'm a finance background, was SEC filings, which is, the Securities and Exchange Commission. All public companies have to file, anything important about their company, they've got to file it. And so all the data is like, terabytes of data available, and, it's all unstructured data. And it's a great way, especially if you're in finance, to learn how to use Python better. Some other tips is make an effort to learn the code from memory and apply it to the project. And a big thing I did was, even if you don't remember the code, make sure that you remember where the code is so you can reference it. Because a lot of what programming is kind of like repetitive, stuff. So if you kind of are able to remember, oh, I've written a for loop before, let me go grab that piece of code and just copy and paste it. I mean, that's like what 90% of programming is, from what I understand. And so some other tips, when you're trying to write a program, write out the steps you need to accomplish the task. Also, make use of the interactive terminal. I use it all the time, especially when working with pandas. You get instant feedback on the data you're working with. And so definitely make use of that. If you're watching this meetup, you're already surrounding yourself with others who are learning. That's a great way of kind of forcing yourself to continually use Python. And bottom line is, make anything, any project, even if it's just like automating the, changing of a Excel file every day, that's a great way to better learn Python, the more you use it, the more you know it. And so this is, if you're going to be working with other people, this is a great kind of tip on how to ask questions. It follows good. So you guys can read that. I don't need to go through that. But again, these slides and are available on GitHub. There's a bunch of stuff on GitHub, and I will talk about that in a second. I actually gave this talk at STL Python a couple months ago, and it was like 90 or an hour long or 2 hours long. And so I have a lot of content on the GitHub, and if something doesn't work, let me know and I'll fix it for you. It should mostly work. I think I was just having an issue with PyFlux. I've got a Jupyter notebook in there that uses PyFlux, and I think it actually used, it's not upgraded to 3.8. So I think there is an issue with that one. So the main part of this talk is really about, again, trying to help Excel users learn Python. And so one of the ways that it's kind of proven that for people to learn things faster is kind of take something and then try to apply the principles to what you're trying to learn. So if an example of that is like, okay, so we know I'm assuming that people know Excel, and so we want to learn Python. So there's a lot of the functionalities in Excel that are kind of the same functionalities in Python. So the goal of this part of the talk is to show kind of that they're similar and kind of provide you with a bridge to learning how to do it in Python. So kind of let's start. So like, here's the first example. So if we're going to install the application, with Microsoft Excel, you use your setup.exe and you install Office, right? And so it's the same thing with Python. With Python, you go to Python, you download it, and you install it on your computer, and you just walk through slide, and you walk through the installation process. And so this is a little caveat, little asterisk here. So what I just showed you was this is the kind of the core installation of Python, CPython, like the vanilla Python. I use Windows just because that's kind of what I've used, and Anaconda distribution. This is my personal preference. Anaconda is a great distribution of Python, and I highly recommend it, especially if you're going to be working with scientific libraries like SciPy, NumPy, Pandas, because trying to install those on Windows is nearly impossible. So I was just going to save you some time and just install and use Anaconda. It's the same installation process. I just install it in my C directory like this, and ready to go. So, just like, Excel, again, coming from Excel user, if I want to start Excel, how am I going to start Excel, right? Oh, we just click the icon, right? That's pretty simple. All right. So how do I do that in Python? So Python, you better, you can open up a command prompt, and you type in Python, and Python, after you install it, Python will start, and you can work with Python in the REPL. This is the interactive terminal. It is awesome. I maybe like have used this way like a couple times. So I don't usually use it. Typically, I use like a IDE. I prefer PyCharm, which is really awesome. You get some really cool features, and it kind of manages everything for you. And so again, I use PyCharm, pretty awesome. And so another nice thing with Anaconda, trying to kind of learn how Python works. And again, this is kind of coming from experience. It's a little bit difficult to kind of wrap your head around like Python in general. And so one of the nice features about Anaconda is that it comes with this a GUI, like a interface. And so you can click through the interface and kind of get the hang of like, what are packages? How do you install packages? What's the environment? Like, it's kind of like a nice transition to doing that all through the terminal. So if you're brand new to Python, I would recommend checking out Anaconda Navigator. And so like Anaconda Navigator, you get like, you can launch Jupyter notebooks, you can create environments, install packages through it. And so it's really nice and an easy way to learn kind of like the different functionalities of Python, or, you know, that you can do with Python. And then once you kind of get the hang of it, then you start using the terminal, and then you're off and running. And so, you know, so we've figured out how to install Python. We figured out how to start Python. And so the next thing is like, let's work with some data with Python. So, you know, again, these are just examples. I would love feedback. If you guys have a better way of explaining this, I'm really open to input, but this is kind of like the way that I thought maybe would be a good way to bridge both Excel and Python. So, you know, when you're using Excel, you kind of store things in cells, right? So if I'm going to store Google and then those numbers, that's kind of like how I'd store it in Excel. And in Python, you can kind of think of that as like it's called a variable. And so, you know, on the right side, we want to store the string goob in the variable ticker. We want to store the price in the price variable, and then we want to store 400 in the shares variable. So they're kind of similar, not exactly the same, but you can kind of think of them the same. And so, you know, typically you're going to work with multiple cells in Excel. And so, for example, you know, on the left side is, you know, what it looks like in Excel. So if we had a bunch of tickers in the column, you know, that's kind of like how you would do it. You just put it down, whatever. And you can also do it, you know, to the side, A, B, C, D, it doesn't matter. But, you know, something that might be equivalent in Excel, in Python, would be something called a list, where you basically store the values in it's designated by the square brackets. And you kind of follow the same. And so after you store it in this, then you can access the list in Python and do different things with it. And so there are other data structures that have kind of pros and cons. You can also use a tuple to store it. But the problem with tuples is you can't change the values after you've created it. You'd have to create a new tuple or tuple. And then there's another thing, dictionaries. And the things with dictionaries is they contain keys and values. You know, you can't repeat keys, but you can repeat values. So a key would be here. And so you can kind of think of it as like, here you might have a key, you know, it's an A1, A2, A3, A4, or you can kind of do the same thing, and, you know, you figure out how to use it. And I've got some examples that I'll go through here, but they're just kind of like ways of storing data. And then there's sets where, you know, it can't change in the sequence of values, and they're non-repeatable. And so, you know, again, these data structures have different use cases, and, you know, you'll have to look into it. But this is kind of like an overview of the data structures. So in Excel, you also have these things called built-in functions, which are formulas you can use out of the box, right? So say, for instance, I want to use the sum function, right? I want to sum a couple values. I just go in Excel, I click little FX, and then brings up this, and you put in the values, and you press enter, and it sums up the formula. So that's a built-in function in Excel. Python has got built-in functions too, and they are right here. And so these are all the built-in functions that you can use out of the box in Python without installing anything. And, you know, you can use, it's got a sum function, so you can take numbers and you can sum values just like Excel. So, you know, again, trying to kind of show the equivalent from Excel into Python. And so the hope is kind of, it'll make learning Excel or Python a little bit easier for you. So here's a link for an interesting Jupyter notebook that talks about built-in functions. You guys can look at that. Again, my slides are, the links are in the GitHub repo. And so moving on from built-in functions. So Excel also comes with pre-installed add-ins. So it may not have used them before, but it does. And so one of the ones that I've used before is the solver add-in. And so in Excel, if you wanted to use a pre-install add-in, you go to the Excel add-ins button, and then you just check it and press OK, and it kind of loads it up for you, right? And so after you kind of complete this process, you can actually use these add-ins. So yeah, so after you enable it, then you can start using these functionalities. So we enabled the solver add-in here, and then it gave us abilities, a bunch of data analysis abilities, like moving average right there. So now after we enable the add-in, then we can use the functionalities of that add-in. So Python has got a bunch of add-ins, and it's called the standard library. And the standard library contains tons of different packages or functionalities that give you, like, I mean, there are tons of, I don't know them all. I use a bunch of them. Glob is one of my favorite ones. Glob lets you find all the files in a folder pretty easily. But just like in Excel, we have to basically we have to enable the add-in before we can use it. So that's what the import function is. It's the same thing as checking the box in Excel. It's import glob. And then once we import glob, then we can use glob. And so this example looks for, in the current directory, all the files that end in .py. And so again, it's just like in Excel. You got to enable the add-in first, and then once you enable it, you can use it. And it's kind of similar. And so Python or Excel also has kind of external add-ins. And I don't know if you haven't used Excel for a while, this is kind of a newer functionality that you can. They got basically an app store that people post their add-ins, and you can download and you can run the add-in after you've installed it. So like here is the example of Excel. We went to the get add-ins. We searched for something that we wanted to add to Excel. Maybe it's Wikipedia, and then we just click add, and that enables the add-in for Excel. And so Python has got something similar. It's called the Python package index, or PyPy, and it works the same way. You can search for packages that you want to use. Most of the packages are on GitHub, but some are hosted on other sites, and you can actually go to the source code. But if you find an add-in that you want, you can just type in request, or you can type in the name of the package. And so this example uses request. So request is an awesome library for downloading content from the internet. And so if we wanted to figure out how to install the add-in for Python, we go to this website, pypy.org, and search for the package. And then once you find the package, it tells you how to install it. It says pip install request. So that's how you install a package for Python. And so, you can open up your terminal and then type in the command pip install request. And and this is how you install it. So it's kind of like the same. You have to figure out what add-in that you want. You need to, figure out how to install it. Typically it's pip, or you can use conda. And then once you install it, then you can use it. And so actually, this is going back to Anaconda. The cool thing about Anaconda is it's visual, so you can kind of get a sense of all the different packages. And so you can actually search for the package in the GUI and search through there. So Anaconda's got its own repository that it installs from, but it's pretty similar. But from my understanding, it's built to it's optimized for Anaconda. So anything that you're installed with Anaconda should work. But this is just an example of how to use the GUI and install the parser. And again, this goes back to what we were talking about earlier. So in Excel, you have to enable the function, and then you can use it. And so Python's the same way. So in order to use the package that you download, you have to import it first, and then you have access to the different functionalities of a package. And so this is an example of how we installed the request library. After we installed it, we can use it. And so we have to import it first, and after we import it, we can do whatever we want with it. So this is an example that import request, and then we're just requesting Google's website, and then we're getting the data from it, pulling it in, and we're just printing the contents of what we got. And so that's kind of like the first 50 characters or something of the content. And so this is another example. So file types, so in Excel, you can work with a lot of different file types. And these are just some of the few file types that you can work with. Python, you can work with those file types and more. You can work with pretty much anything. And so, once we figure out the file type and we say we want to open a file, in Excel, we just go to the file, open, and then figure out what file we want. And we just click open and it opens the file. So in Python, there's a couple of different ways of opening files. This is kind of the basic like beginner's example. It's not recommended. I mean, whatever. Everyone has their own opinion. But the more preferred way of doing it is kind of using the with statement, because it automatically closes the file after you're done using it. So this is kind of a preferred method. And so that would give us access to the data, and we'd have the file open. In Excel, so the next thing we'd want to do is we want to look at the data. And so Excel is pretty nice that it automatically displays the data right there in front of you. And in Excel or in Python, we got to do a little bit of work. And so again, this is using the simple open example. And so we want to see the data. We open the file, we go through each of the lines, we print the line. And so that's kind of like displaying the output of the file. It's just a simple example. Yeah, so that's displaying the data. And so another example of things that are kind of similar between Excel and Python is that, in the left side is Excel dates. You work with dates a lot in Python or in Excel, and, Python actually has built-in functionality. You can actually download kind of more advanced packages from the PyPy, but the datetime in the standard library does a lot of stuff that does most of the stuff you need. And so these are kind of some examples of how would I want if I wanted to print today, and if I wanted to parse a string and get into a datetime object, that's the second one. And then if you just need like now, like what's the current time now, that's how you do it there. And so this part is probably we're going to get a little bit more complex. If you're an Excel user, this is a word of caution that what we're about to discuss is a little, from my opinion, when I first started Python, it's a little bit complicated. And that's what's a for loop. It's called a for loop. And so we're going to walk through an Excel example, and then we're going to show you how to do it in a Python. And so kind of, again, any feedback on maybe making this better would be appreciated. So best example I could think of is kind of like the fill down function in Excel, which, like, say we've got this data here, and it's so what it is, it's Walmart data, it's total sales and total expenses by year. So each row contains a year and then the sales for that year and total expenses. And so say, for example, we wanted to create a new column for the profit, which, profit is calculated revenues times expenses. So basically, we want to take column D and subtract column E. And then we want to put those values in column F. And so this is just an example of how we would do it. So the steps we need to create we need to create a new column on the right side, fill in the column. And so we would then create a formula, basically subtracts the cells from D and E. And then you press enter, it gives you the value, and then you fill down the formula for each of the different rows. And this will automatically fill the rows down with the formula and the relative cells. And so that's going to give us this value. So, another way of thinking about this is that for each row year in column F, we're going to subtract expense from sales. So now we're going to get into what Python and what a for loop is. And so a for loop is kind of like a fundamental concept that you got to learn. And once you learn it, you are ready to go on to the next difficult thing. So not difficult thing, but the next challenge, I should say. So say we have, so this is a simple example of a for loop. And so say we have a list of tickers right there. And we want to go through each ticker and just print it out onto the screen. So this is like the typical for loop in Python. This is it. It doesn't get it can get a little bit more complicated than this, but this is use it every day, all day. This is how you do a for loop. And so, if we're gonna basically what we're going through is we have the tickers here, and then we're saying for each ticker, and then we're going to print the value. So it's going to go one by one, Google, Microsoft, IBM, and Tesla, one at a time, and it's going to fill in ticker here, and it's going to print it out. So this is what the output is. So I like to use real example or more complicated examples. So if we go back to that Excel or that file that we used, that we saw before with the Walmart data, this is actually using that Walmart data. And again, these are in GitHub. This is under the 0-1 presentation examples. And this is 0-4 perform calculation, no comments. And so what this example does is that it's going to import some standard library that going to give us some functionality that we can use. The CSV file is going to allow us to parse CSV files. And the date time is going to allow us to parse the date. So if we go back to the data that we're working with, this is the data that is actually going to be working with. So, we can say we have a ticker, column name, and year end, total sales, and total expenses. And so that's the data we're reading in here. And so we are going to open the file, and we're going to skip the header, and we're going to do a for loop over each of the rows. And again, we're trying to calculate total profit for each of the years. And so we're going to iterate through. We're going to go through each row, and we're going to perform various calculations on the data. So in line 12, we have, and so I actually have, I should probably get the comment one out. But I have got one with comments in it that kind of hopefully, and the links down here, that hopefully provides more context in what we're doing here. So, this is what the data, so if we were to print out the row here, this is what the data looks like. And so you can kind of think of it as it's going to go through and perform these functions are going to be performing operations on the data. So we are going to look at row 2. So row 2 would be the date here. So we're going to take this, we're going to, you can substitute it in, and it's going to parse it into a date object. And if we print it, that's what it looks like here. And so once we have it into a datetime object, we get some new abilities. And so we can actually take that object and we can ask for the year. And so we just get the year back. So I'm going to store that in a variable. So yeah, and so, when we are parsing with this, the data is, there's string values. So we need to convert them to integers so we can do the calculation of.
Hey, Ryan, do you mind making your screen a little bit bigger, just the font?
Yeah. Is that better?
Oh yeah, that's perfect. Thank you.
Yep. Yeah. So again, we are iterating. So we have all of the rows in that we're iterating through, and then we're going to grab one row. So you can imagine that a row is this exact thing here. So we're going to pass this down here. So we get a date, and then parse with the date time object. And then we need to, so we're going to look at row 3. And so this is kind of saying we're going to take the third item in the list, which is this right here, and we're going to convert it to an integer so we can do a calculation on it. So that's what we named it as row sales. And now it's an integer, we can do stuff with it, but we can't do stuff with the expenses because it's still string. And so once we convert number 4, which is the expensive, we can now perform a calculation on that data. So we're going to basically take sales minus expenses, and we're going to store it as variable, and then we have that data available to call. So like if we ran the program, this is basically the output that would you generate here. And basically, again, you can run the example. I don't know if I want to run it. I heard not to do live demos, but yeah, this is going to be output. And again, if you have any problems or any questions, feel free to reach out to me. I'm happy to help you. Just got to message me, and I'm willing to help. So that's the example there. And so I wanted to show a kind of a vanilla Python example because so this is vanilla Python. It's a little difficult. I'm not going to lie. And so I don't typically use if I'm doing data analysis, I don't typically use vanilla Python like this. What I use all day, every day is Panda, just Python package called Pandas, and Pandas is pretty awesome. And it makes working with especially like comma separated values or Excel files or any types of it makes working with it like a breeze. And so this is kind of an example of Pandas. And so again, what I tell people, Pandas is like its own language. And what I did was I learned Python first, again, the core function in Python, and then I kind of went to Pandas because Pandas is a little bit complicated. It's not like Python. It's got its own syntax. So just be aware of that. And there's a lot of the similar function objects work kind of the same way, but it's a little bit, it's different from Python. So it's just a warning. It is, and so kind of a tangent here. One of the ways that I learned Pandas really well is by kind of figuring out a project to work on. And I actually, again, those SEC filings that I mentioned before was a great way that I learned how to kind of use a lot of the functionalities of Pandas. So I'm really kind of like well-versed in Pandas after, parsing unstructured data from these SEC filings. So if I could recommend anything, is kind of find a project that you can, and data that you want to work with, and just kind of like manipulate data with Pandas. And that's how I learned Pandas. But this example, it's really awesome. Again, Pandas is awesome. This does the exact same thing as these lines did up here. So in 19 lines, we can accomplish in 10 lines. And so what we're doing here is we're reading a CSV file. And then in line 9, it's kind of like how you work with Pandas data. And so we're going to reference the total sales column, and we're just going to subtract everything from the total expenses column. And then we're going to store it in a new column called total profit. And so that's all. And that's, I actually didn't even show how to save this file. I didn't even show how to save this because I didn't want to. It's too much work. So again, I typically use Pandas, but again, it's a little complicated. And it's not like Python, so it's kind of like its own language. So just be aware. And so this is actually what the output looks like in Pandas. And so what we did was we created a new column. This created a new total profit column, and we actually saved it as well. Again, I've got links here with examples that are have got more comments in them, and a couple more examples, and just showing different ways to do it. It's like in this one, I show how to kind of calculate profit margin for the data, and then sales growth. So those are kind of like when I was working these funds. These are type of calculations that we did. So here's a few examples. Again, this is links provided in the presentation. We only have 2 more error messages. So Excel, you get error messages, and you get these pop-ups that tell you something's wrong, and you gotta, how would you figure out how to solve this problem, right? Well, you typically just go to Google and you search for it, right? You just type in what the error message is, and then you find the solution. That's pretty easy. Well, Python is the exact same way. You basically, when you're reading an error message, it works from the bottom up. So basically, the last line is basically what is wrong with it, typically. And so you can basically take that last line and you can search it on Google, and you will find probably 1,000 answers to that same question. I mean, people have asked the same question as many ways as you can think of. And so they're very similar, the ways those work. And so this is another thing, file version history. Excel actually has file version history. I never really used it, but this is just kind of like a recommendation. You can check out Git. Git is kind of file version history, and it's will save your butt if you're working with files. And so that is that part of the presentation. I guess I can walk through the repo real quick. It contains a ton of stuff. And so what the repo actually contains is are examples of my projects that I created in order to better learn Python. And so this first folder contains examples from the presentation. One of the first projects that I worked on was a Selenium example. So I'm always like looking for data on the internet because we always are using data in the finance markets. And so this example, basically, I saw data that I wanted from internet, and I figured out how to export that data in. And just so happened that data was written in JavaScript. So you can actually use like something like the request library. You have to use something like Selenium because of just the way that the HTML renders on the page. So, that was like one of the projects that I used to better learn Python. I actually created another one where it's like, there's this website called Savari that's got books on it. And I was like, oh man, wouldn't it be nice to read those books as PDFs? And I was like, I'll just, create a Python script to, download books. And so that's that example. And so then, this is kind of like the roadmap I was trying to talk about at the beginning. It was, these are kind of like how I progressed to better learn Python. And so after, got the data from the internet, then I ran into the problem. It's like, I got a ton of data. I got to download now. I got data that I can't handle with just one Python process. And so, then I started looking to the message queues are pretty awesome. Celery basically lets you download stuff concurrently or multi-process very fast. So you can download things 8 times faster than, if you've got an 8-core processor. So that's pretty awesome. And so these other analysis and visualizations. So if you want to check out some visualization stuff, there is some Jupyter notebooks in here that got some really cool visualizations using like Matplotlib. And so these examples contain just everything, like any type of example you could think of. So like this one contains just like all the different ways you can graph stuff in Python, right? And so this is another one. This is visualizing sport data. So that's in the visualization folder. And then so in the other analysis folder, if you're kind of like a data scientist or you want to look into data scientist, these ones actually contain some really interesting like regression type analysis on like sales data. This one, dynamic linear regression. Again, these ones, they don't work, but you might be able to get the gist out of it because these are, I think, PyFlux is only written for Python 3.5, and I upgraded everything to 3.8. So you might have a problem with PyFlux, just FYI. And and so I have a Flask, which is kind of like a web browser. Airflow, kind of, I didn't get a chance to talk about it, but after you kind of get a grasp on Python, you really have to think about like the way that you're managing your data. And Airflow is a great tool for scheduling stuff. If you need stuff to schedule and you need to perform complex calculations, Airflow is awesome. So that's got an example in there. And if you're just looking for like your basic Python stuff, these would probably be the way to go. And these just contain the pandas, data analysis, data visualization. And in here, it's actually a notebook. So if you want to check out some panda stuff, I definitely recommend Daniel Chen. If you search his name on YouTube, he's awesome. He's got like 3-hour presentations on pandas, and he will show you everything. So this is just a notebook from one of his tutorials, and it contains kind of like some of the more complex panda stuff on here. So like melt, filtering stuff, pivoting stuff. So that's a great example. Some more, and this is kind of like some of the like basic pandas functionality. So if you kind of like definitely if you look through the Jupyter notebooks, they contain a lot of stuff. And so like, just kind of stuff that I thought as if I was first starting out, this is kind of stuff that I wish I kind of like would have had in one place. And so that's kind of like what this repo is. And again, if you find something that's wrong, just message me on LinkedIn. I'm in the Chippy Slack, and I'm happy to help. If you have any questions, I am happy to help. Again, one of the nice things about the Python community is everyone's really nice. And if you ask for help, people are going to help you. So, don't be afraid of asking for help. And people are very friendly, most people. So that's pretty much it. I guess if anybody's got any questions or,
Great. So we have. Thank you very much. That was an awesome talk.
I cut it short. I've got more stuff. If you go down to slides again, this is like a 90-minute talk. There's a data management slides. These are all slides, and then these are links to the code for the Jupyter Notebook. So again, if you have any questions, feel free to just message me.
So one question we have from Ali Sivji. Are there any resources or suggestions on learning pandas? Or is doing it just the best way to do it, or
yeah? And so that is the best way to do it. Again, so Daniel, like I said, Daniel Chen has got like a 3-hour tutorial that he walks through, and he doesn't do just like basic stuff, but he also shows you kind of like some of the more advanced stuff, like the melt stuff, and so he does that stuff. But if the only way that I learned pandas was by doing it, like it was by trying to working with data. Like I said, I used the SEC filings, I got the tables, and I just tried to extract those data, like it was unstructured, complicated data. And that's how I learned it. Like, and I can do it from memory now. And so, again, and don't be afraid of like trying to, don't be afraid to like reference stuff that you've done before, because, it's complicated. It's tough stuff to learn. So don't be afraid.
Cool. So is there, so if you're new to Python, and let's say you're really good at Excel or have been using Excel for a long time, and you want to make that jump, it looks like that. Like, what other resources might you have, or advice would you have to them in order to make that jump, rip off the Band-Aid? That Anaconda studio looked pretty neat.
No, that's I mean, and the Anaconda is nice because again, you don't have to deal with some. It's kind of a pain point in Python. The Python community is packages, and so Anaconda kind of it's very beginner friendly, and I would totally recommend it. You can actually install it on Linux and Mac, and again, you can launch the Anaconda Navigator to kind of get a feel for like what are the different things that you can do with environment and stuff. And so once you kind of get the hang of that, it lets you install packages using the GUI. And so, I highly recommend it. But there are other ones. I don't know what they are, but there are other ones.
Great. And are there any integrations? Like, would you ever use both Python and Excel with the same project?
Yeah, I mean, so way that I use Python and Excel. So especially when I'm working with stakeholders or business users, they are very, very keen on working with Excel. So, they will be sending you Excel files, and you will have to look at the Excel files. And, I still use Excel a lot to look at the data, especially if it's, manageable, because it's, nothing is, it doesn't get as easy as Excel and opening a file and just looking through the data and maybe even performing some sort of calculations. And then, really what I decide is when I want to use Python is when I want to like automate. If I want to automate something that's something repetitive over and over, that is kind of when I jump into Python. Or if the data is too big, I will jump to Python. But yeah, I still use both of them. I don't use Excel nearly as much as I used to because I've kind of learned how to do it in Python. But yeah. If anybody's got questions on like, oh, how would I do something, like, I'm happy to help. So just got to message me, and again, pretty open for anything like that.
Great. Thank you very much for your talk.
Cool. Yeah. Thanks a lot. Yeah. Thanks, guys. Also really great job on the videos on YouTube, because it's very, very professional.
Thank you. Yeah.
And thanks for the hard work.
Thanks. You too. All right, well, that's Chippy for today. Thank you for joining us. And we had some 3 awesome talks from 3 awesome speakers. So really appreciate everyone joining us and those speakers giving their talks for us. If you want to stay attuned to future videos on Chippy, the Chippy channel, please like and subscribe. We have more content coming out, as I mentioned at the beginning. There's a bunch more meetings that we're going to be live streaming. So stay tuned. Check the chippy.org website, and I hope to see you soon. Have a good night.